Good evening, everyone. I think let's go ahead and get started. Although we have a kind of small turnout in the house tonight, perhaps people kind of glued to the ongoing election coverage, which I also, of course, am quite interested in. A couple of additional people joining here just as we get started, but we'll try to kind of expediently get through things tonight as we're talking about our sixth and next to last database of the semester, the ultra high performance key value data store of Redis. So yeah, this is our last genre of DBMS, the key value data store. We'll be talking about Redis this week, and then next week the effectively infinitely scalable DynamoDB, which runs on top of the Amazon AWS infrastructure, meaning that it has access to the resources of literally tens of millions of servers. So pretty amazing scalability and performance there. But yeah, what we're going to be talking about today is the ultra high performance Redis, where we talk about performance in not thousandths of a second or milliseconds like we have been with our other DBMSs, but millionths of a second or microseconds. So, hundreds, if not thousands of times faster performance, which is kind of neat. And we'll see some examples of maybe not that big of a difference, but pretty big differences a little bit later tonight. So in preparation for tonight, you should have watched lecture series 12, which was 4 videos making up just about an hour and a half worth of content. So expect about an hour and a half, maybe an hour to an hour and a half of content tonight. And then also read chapter 8 in the Perkins 7 Databases in 7 Weeks book. And then also chapter 7 in the Harrison book, which talks about these ultra high performance in-memory databases. So some really good and interesting content there. And I know we kind of hit around some of the topic in the Harrison book in our class discussions, but I hope you are keeping up with that, because that's valuable knowledge and stuff that might be on the exam and just kind of also contribute to your overall understanding of non-relational databases. So hopefully you're keeping up with the asynchronous content, as well as the reading, as well as your assignments and the case project work and all of that. Also, in preparation for tonight, you probably encountered some issues interacting with the graph gists on the Neo4j website. So this was working when the assignment was initially put out there, and then I had a student reach out to me a couple of days ago and said, well, when I click on the button that says show code or view code or something like that for the graph gist, I get this error message on the web page. And sure enough, I got the same error message, and I've reached out to Neo4j via their Discord channel, via email, and via trying to place a phone call, and wound up leaving a message on their support line. And yet the problem continues to persist, and I haven't been able to actually interact with a human being in any way. So hopefully that will be resolved soon. So in those hopes, I am kind of delaying, with no specific date in mind, the completion for assignment 4 right now. And if this isn't back in the next couple of days, we'll figure out kind of the fair thing to do that will also contribute to your learning. So if you got in there soon enough, you might have actually been able to access the graph gists, in which case that's awesome. But if not, we'll figure out the best way to proceed, and I'll let you know what we decide that is. So yeah, with that, we are getting into kind of our last couple of weeks of class. So of course, tonight we have Redis. Next week on November 12th, we'll be talking AWS DynamoDB. And then on November 19th, kind of taking a holistic view of all of the databases we've covered this semester and talking about this idea of polyglot persistence, or the concept of using multiple different DBMSs together so that we can take advantage of all of their unique strengths while also avoiding kind of the weaknesses, right? Because we've talked about the pros and cons of these different databases and how it's not just a one size fits all type of situation. So we'll think about how these databases can work together, and then also talk a little bit about some maybe emerging data management technologies that we haven't been able to address in the class. Things like blockchain and time series databases and some other kind of emerging tech. So that's a little bit of wrap up coming here in about 2 weeks. And then on November 26th, we'll have our second round of case project presentations. So in preparation for that, here in the next couple of days, I will be reaching out to each one of the groups to set up time to have another one-on-one meeting, and also distributing your feedback on your part one of the case project, which I'm sure you are really awaiting that anxiously, and I'm sorry I haven't gotten that back to you just yet. My semester has been a little bit wild and crazy and kind of extra busy this time, and I know you all are busy as well. So I'll get that feedback to you just as quickly as I can, so we can do even bigger and better things for Project 2. Right? So that's November 26th. That will be our last regular class meeting, and then we will wrap up the semester completely on Friday, December 6th, which is our final exam. We'll devote 2 hours to that from 6 to 8 p.m. On December 6th. That'll be administered online via Canvas using the lockdown browser, as online exams often are. I don't expect this will take you the entire 2-hour time period, but you'll have that time available if you need that. All right, so that's kind of the logistics for the rest of the semester. As far as the logistics for tonight, like we do most times, we'll have just a very quick overview of Redis and kind of our create, read, update, and delete commands and the stuff that was covered in the asynchronous video, and then move into some new content that you haven't seen before. Revisiting our familiar U.S. counties data set and looking at how we can interact with that data set in Redis. And then also kind of quantifying and demonstrating some of the ultra high performance in Redis. So I've said several times, and we'll say several more times, about how the super high performance of Redis is kind of what sets it apart. But we'll actually put some numbers to that tonight and kind of compare and contrast Redis to Postgres, and then we will be wrapped up for the evening. All right, so this is I guess now the 6th time we've seen this slide, since this is the 6th database we're talking about. But of course, Redis is a key value database, and I mentioned in a previous lecture that really this idea of a pair of a key and a value is pervasive across all of the databases we've talked about, right? In a relational database, you have your primary key and then the values of all of the attributes that are found in that tuple, right? So you have a key and some set of values. Or in a document database, we had a document ID, and then the value would be the entire document that goes along with that, right? So it's a very kind of normal concept, but with our key value data stores, we're really kind of stripping things down a little bit to their just rawest implementation that we can, without a lot of extra bells and whistles, to get some very high performance. Now, we will find that Redis does have a few niceties as far as different data structures and some set operations and some basic programmatic stuff we can do. But for the most part, we're really focused on kind of no frills, high performance, and very simple access. And when I say simple access, I really mean this in two different ways. One, the Redis commands that we use to interact with Redis are pretty straightforward and simple. There is no sophisticated language like structured query language or JavaScript or our weird kind of HBase nomenclature that we had to use. We do have something like 260 different commands, but for the vast majority of what we do, all of our commands are just some variation of set and get, right? We use set to write things into the database and get to get things back out, right? We have some variations of that, like mset to set multiple values, or hset to set values into a hash data structure, right? But really, it's mostly revolves around this idea of set and get. So pretty simple language, really, once you understand the pattern and the structure of it. But also our access is simple in that we don't require any special client, any special driver, any special kind of network protocols. Redis just listens on this port 6379, and we can send just raw commands over the network directly to Redis, and it will immediately send us the data back. Right? So if you remember when we first started using Postgres and we had to install a SQL client like dbeaver or SQL Workbench, and then we had to install the driver to connect that client to Postgres, and we had to provide the address of the server and the username and the password and the database we want to connect to and all these things, there was a lot of overhead in establishing that connection, right? And once that connection is established, we could work with it pretty easily, right? But Redis doesn't have any of that overhead, including, and we'll talk about this in just a moment, any type of authentication, at least not by default, right? Because anything we're doing with a driver or a client or with authentication is taking extra computing resources, extra memory, extra CPU cycles, and that's not what Redis is about. Redis is about being absolutely as fast as it can possibly be, right? So the simplicity of the way we interact with it is part of that, right? So like I've mentioned, again, a couple of times, what makes it unique, very, very fast, and also that it is generally not used for persistent storage. So as an in-memory database, and when we say in-memory database, what I'm talking about is that the data is all stored in memory, right? In the random access memory. So not on persistent storage like a hard drive or a solid state drive or a flash drive or anything like that, but in your kind of working memory, which by its very nature is ephemeral, right? So whenever you boot up your computer for the first time of the day, your operating system and some of your data and things like that are read off the hard drive, which is relatively slow, and stored in your random access memory, which is many hundreds, if not thousands of times faster, right? But the downside to your memory is that when you turn off your computer, when you remove power from memory, everything that's in memory goes away, right? So that's why we have to have this slower persistent storage of your hard drive or solid state drive or whatever it is you're working with. So that's the downside of Redis, is if your server crashes or if you power it off, by default, everything in Redis is gone, okay? So generally the way we're going to see this used is that we have some persistent data storage, like a relational database, like Postgres or like MongoDB or Neo4j or whatever, where we're storing our data long term. And then whenever we need to be able to very rapidly access our data, copy that data out of our persistent data store into Redis so that it can be used in that very rapid manner, right? And this is why one of the very popular use cases for Redis is to be used as a caching service. Okay, so if you think about requesting data from a relational database, well, that's going to take a couple of milliseconds to pull that data out, right? Maybe 100 milliseconds to get that data out. Well, if we can store a copy of that in Redis, we can ask for that data from Redis first and it return it in a few millionths of a second. Or if it doesn't have that data, it can turn and go ask Postgres. So that'll take a few hundred milliseconds, right? A few hundred thousandths of a second. And then Redis can store a copy of that data, so the next time someone asks for it, the response can be much, much faster, right? So that's a normal use case for Redis. And we'll talk about a few other use cases throughout the night. But yeah, generally not your long-term persistent data store. It's really used more for doing some very high performance interactions. And of course, the fact that it is an in-memory database, we're kind of limited in size to however much memory is in our server, which these days could be several hundred gigabytes. We can have very large amounts of memory in modern and cloud-based servers, but still you're not going to see this scaling out to be carried over many, many servers, like how HBase was able to kind of horizontally scale, or how it could have so many instances of CouchDB or something like that. But again, scalability isn't really the point of Redis. It's the performance that is the point of Redis. So Redis, REDIS, stands for Remote Dictionary Service. So just like back in the old days when we had dictionaries, these big thick books made of actual paper, right? And you would look up a key, you would look up a word, and there would be some value associated with that word, right? The definition of the word is the value that's associated with that key, right? So just like we look up things in a dictionary, we can look up values in Redis. So it is again a key value at its core, key value data store at its core, but then does have a few niceties like some data structures, lists, sets, hashes, ordered sets, things like that. And we can do some basic set theory operations. So we talked about previously relational databases are based in set theory branch of mathematics. So set operations let us do things like union, intersections, and differences between data sets. So again, very fast, we measure our performance in millionths of a second or microseconds instead of thousandths of a second or milliseconds, like we've talked about with most of our other databases. And it is said that Redis can process upwards of 100,000 write operations per second. So I have pushed our installation of Redis in a couple of different ways, and I have maxed out around 75,000 write operations per second. So I don't know if just there's some limitation of what we're doing in AWS or whatever, but that is still pretty darn fast to be able to write 70,000 items into your database in 1 second. We'll see performance kind of along those lines tonight. Okay, so we already talked about this idea of being an in-memory database. Now, I kind of preface that with saying that is the default configuration, because certainly we can configure Redis to either constantly or periodically write data out to disk, right? Of course, there is going to be a performance penalty for doing this, right? But in certain use cases, maybe you want to say, look, I want Redis to be extremely high performance 99% of the time, but so that we can recover from a crash without having to reload everything from Postgres or MongoDB or what have you. Maybe let's write this to disk every 5 minutes or every hour or every whatever makes sense. And if you search around for a bit, there's actually a lot of people that have kind of done some custom configurations and installations of Redis to try to make it work more as a persistent data store that still gives you high performance. So people are doing a lot of neat things with Redis, but by default, we're looking at the data being stored there, being kind of thought of as ephemeral in nature, and we would want to have our persistent data store somewhere else. All right, so I mentioned we have, I think it's something like 260 Redis commands. Many of them look a little weird at first, but once you kind of get this idea of set and get and all the variations for using multiple values and hashes and sets and things like that, you kind of can understand this pretty easily. So the general format is that we're going to have whatever the command is, whatever key it is we are reading or writing to, and then the value that we are interested in. And like most of our other DBMSs, the commands themselves are not case sensitive, but our names of the keys and the values are going to be case sensitive. So that's nothing that should feel foreign to us just now. So we do have a basic text-based Redis CLI utility installed on the same server that MongoDB and Neo4j and Postgres are running on for this class. So sorry, I meant to email you the details of that a little bit earlier, but it just got to that a couple of hours ago today. But basically, because of the kind of security situation of Redis without needing authentication, the way that we secure Redis is by kind of segregating it on our network. So we cannot connect to our Redis installation remotely like we have for some of our other DBMSs. But if you SSH into the shared server that we have, and you just run this command redis-cli, that will connect you directly to our Redis instance. So we'll do that a little bit in class tonight. We're also going to be connecting directly to port 6379 using a utility called netcat, which is NC is how we invoke netcat. And for any like uber nerds who do computer networking, netcat is a pretty well-known tool. We consider it to be like the Swiss Army knife of networking because it enables us to make just kind of raw TCP connections over the network and kind of emulate a lot of different protocols and send data in different ways. But just a very lightweight utility to allow us to send commands directly over the network to whatever type of server application we're interacting with, but in this case to Redis. And the reason we're going to be connecting in this way tonight is because for some reason the Redis CLI does not allow me to just copy and paste commands. And like I do on most evenings, I have a notepad file or a text file here just full of commands that we're going to be copying and pasting to run through some of our demos. So in order to copy and paste, we have to be using netcat, and that is what we're going to do. All right, so one other thing before we get into the demo that I wanted to look at or wanted to point out here is if you keep your eyes on the news, you'll fairly regularly see instances of companies having, data leaks and data breaches and other unfortunate things happening. And this is an article that came up, I guess, about 2 years ago now. This is October 27th of 2022, where Amazon accidentally exposed a whole bunch of data about viewing habits of customers that were using the Amazon Prime Video, right? And if you dug into the article just a little bit, you'll see a couple of things that seem very familiar to our kind of understanding of Redis. So to be clear, this was not an installation of Redis. This was an AWS technology called Elasticsearch, but it works in a kind of similar way to Redis, and especially with the kind of authentication scheme here. And if you see here in the second paragraph, the database was not protected with a password, and thus the data can be accessed by anyone with a web browser just by knowing its IP address. So that is quite unfortunate, right? If you've got something that is not password protected, the general recommendation there is to completely segregate it from, especially the internet, but probably from the vast majority of other clients on your network, right? And we also see here at the bottom, there was a deployment error with the Prime Video Analytics server. Well, the deployment error being it was put on the wrong network segment, or we didn't have the right firewall rules in place. The problem has been resolved and no account information, including login or payment details, were exposed. Was not an AWS issue. AWS is secure by default and performed as designed. So it sounds like probably what was going on here is we took the information out of whatever the persistent data store was, Postgres or HBase or whatever it happened to be running on, maybe DynamoDB since this is an Amazon thing, and loaded it into this high performance database in order to do analytics. But we don't need to load in all your customer credit card information and login details and things like that. You would only want to log in that relevant data about their viewing habits to do that kind of analytics. So I don't know, I always enjoy kind of keeping an eye out for articles like this and trying to kind of read between the lines and think about what might have gone wrong or what might have been happening that kind of facilitated something like this being able to happen. And so Redis acknowledges that we are not focused on security, right? That Redis is designed to be accessed by trusted clients inside a trusted network. We're going to freely give you this data as quickly as we can because that's what we do. We're high performance. And in order to secure your Redis environment, your Redis server should be mediated by a layer of implemented ACLs or access control lists, right? So access control lists, this is kind of similar to the idea of like firewall rules, right? Or, network segments that only certain trusted clients would be able to access, right? So certainly not everyone on the internet, probably not everyone in your company, probably not all the other servers in your data center or cloud environment. You would probably want to lock this down to just like the one or two other database servers or web servers that have a real reason to actually interact, with Redis, right? So you want to lock this down at the network layer so that we don't have to worry about any kind of like individual user level authentication. Now, Redis does give you the option to enable password authentication, but they explicitly recommend that you do not do this, right? And there are a couple of reasons that we don't want to do this. So you can go into this config file, you can uncomment this line here and say require password and then provide the password, okay? The issues with that, at least 3 issues with that, is one, this is just one single password that everyone has to use to interact with Redis. Well, that's not great. The real reason that we have usernames and passwords, in addition to kind of securing and making our accounts private, but is also to give a level of accountability and auditability, right? That if I'm the only one that knows my username and password, and my username and password was used to log into the database, right? You can come to me and ask me what happened. If everyone's using the same password, it's much less useful for that type of thing, right? Maybe this would keep someone from like accidentally stumbling upon your Redis server and doing something, but it's not really doing a whole lot for your security. Also, the password is stored just in clear text in the config file. So anyone that has a sufficient level of administrative access to the server can just open up this file and see what the password is. It's not really very secret. And then also it acknowledges here in the file that if someone just guessed passwords, Redis is fast enough to handle up to about 150,000 authentication attempts per second, right? So you can guess pretty quickly and try to brute force this. So generally, we want to handle securing Redis by securing your network and segregating it from any untrusted clients. All right, so we're not going to really go through most of the rest of this in a lot of detail because this is covered in the asynchronous content. But yeah, we have a number of different data structures that we can have in Redis, in addition to just our key value pairs, where the value is either a string or a numeric value. We can have hashes that let us store multiple values in one key. So we might have a hash that's something like your student, right? And then within student, you have a first name, a last name, an email address, a phone number, all of these attributes that kind of come together to make up a student. We can have lists, which are ordered, and we pop and push values, or push and pop values onto and off of a list. So a list is an ordered data structure. We also have sets, which are unordered sets of items, and we can use our set theory operators, union, intersection, and difference, to interact with our sets. And then this kind of weird data structure of a sorted set, which is ordered like a list, but our items are unique like in sets. And we can do some kind of different types of operations with that. And we'll see that with our US counties data set a little bit later tonight. So nice that Redis gives us these data structures and still maintains this very high level of performance. So let's see. Okay, yeah, so here's just a little description of the connection, which we've already talked about a bit. So at this point, I'm going to kind of flip over to Redis, and we'll start looking at stuff a little bit tonight. And one thing I will point out, so like our other databases, this is a share, or like many of our other databases, we're kind of working in a shared environment. So if you write anything to Redis during class, maybe preface it with your initials or username so we don't step on each other. But also I will be flushing all the data out of Redis periodically as part of our demos. So again, everything in Redis is kind of ephemeral and temporary in nature. So yeah, we said to interact with, got the wrong window there. To interact with Redis, we're going to just do Redis radis-cli, and that gets us into the Redis command line interface. There is very nice documentation built right into this Redis CLI client. If we just type help and then the name of any command, it will tell us exactly how to interact with that command. If we type help and just start hitting tab, it will kind of scroll through all of our possible data types and commands, which is very nice. So a lot of great kind of inbuilt stuff there. If we type keys and then a pattern like keys asterisk, this will tell us any keys that are currently set. And it looks like someone has been interacting with the database and has already set a couple of things. So I'm going to set a couple of things as well. So I could do something like set, and I'll call this MG student 11111, and give a value of Alice there. And then if I wanted to read that back out, I would just say get MG student 1111, and we get the value that we just set there. We want to set multiple things at the same time. It's mset, and then just the pattern of a key and a value. So I'll say MG student 2222 is Bob, and MG student 3333 is Chris. And then we can read things out in multiples by using the mget command. So I'll say mget mg student 1111 and mg student 3333, and we get Alice and let's see, mg student. I made a typo somewhere. Oh, I have too many threes here. There we go. Alice and Chris, right? The format we get the data back in is not super pretty, right? But super pretty isn't what Redis does. Redis expects that you know the order you specified the keys in. So it doesn't really tell you that this value goes with this key. It's just saying, hey, this is the key, here's the first value, here's the key, here's the second value, right? And it's kind of up to you or your application to parse that and figure out what to do with the data. Okay, so that's setting data or writing data, reading data. There is no special command for update. You just do a set on top of a key that already exists, and that will update your data. And then to delete your data, we use the command del to delete. And if we want to delete everything in our database, use the command flushdb, and there is no warning, there is no protection, there are no guardrails there. As soon as you say flushdb, all of your key value pairs are just immediately and unceremoniously destroyed. So I won't do that right now, but I will do that in a minute. So don't want to disrupt any experimentation you all are doing. All right, we also mentioned in the asynchronous video that we can do some kind of basic arithmetic functions using our increment command. So incr to increment, or a decr to decrement to go to subtract values, and also the increment by and decrement by commands if we want to go up or down by something other than a single number. We said we do have the concept of transactions, much like we do in a relational database. And in the asynchronous videos, we give some examples about where this would come in useful in, say, a banking situation, right? Where we're transferring money from one account to another. That's actually two different operations that happen. You deduct the money from one account and you add the money to the other account, and you want that transaction to be all or nothing. And we have the ability to do that here in Redis. And then also, one of the, I guess, kind of unique things about Redis is this concept of expiration. So since one of the prevalent use cases of Redis is to be used as a caching service, whenever we're caching data, kind of the downside of that is that as soon as we create a cached copy, that copy of the data immediately starts becoming stale, right? It's possible that it would get out of sync with the kind of main copy of the data that's stored in your other data sets. So it is not a technical decision, but a business decision of, okay, we know this data could potentially be stale. What is the maximum amount of staleness that we are willing to deal with, right? What's the maximum kind of out of date that it would be okay for this data to be? And maybe it's, a minute, maybe it's 10 minutes, maybe it's an hour, maybe it's 5 seconds, right? That's a business decision, right? That's an application level decision. But the nice thing about Redis is it does give you the option to put a kind of a time limit on how long a key value pair is going to exist, right? So we can do that with either the expire command or with the setex command, right? So we could say something like, set URL equal to, or I'm sorry, don't need equal sign, URL, we don't need quotation marks around this, I don't think. Right, and so now if we say get URL, we get that value in reply. So we could say expire URL in 10 seconds, right? And so that means that value of www.google.com will only persist in this key URL for the next 10 seconds, right? And then it'll go away, and we would need to refresh that data from our persistent data store if we wanted that. So we'll say we'll expire URL in 10 seconds. If we say TTL, oh, sorry, gotta remember this is case sensitive. So we got the response 0, meaning that didn't work, right? So it's case sensitive. There we go. Now if we say TTL of URL, we can see it's going to be valid for 6, 5, 4, 3, 2, 1, 0 seconds, and then -2. That shows that it has expired. After that point, we try to get URL. Did someone else create a URL attribute? I think that might be what happened. Let's do a setex of mg URL. I'll heed my own advice there. setEx, oops, I gotta give the, there we go, TTL MG URL, 5 seconds. And now if I, get MG URL, I should see that. But once that is expired, if I say get MG URL, yeah, there's no value there anymore. I think someone may have set a URL value on top of my URL value, and that's what happened. And that's okay. I'm not mad at you about that. All right, what else? What else? I think at this point, oh yeah, so in the asynchronous content, we talk about different namespaces, right? Where we can have, it's very similar to having different databases, and we use the select command to switch between our namespaces. So like right now, we see all of these keys in the default namespace. If I were to change to another namespace by saying something like select one, and then I look, there are no keys here, right? So you see here I'm in namespace 1. If I switch back to namespace 0, that default namespace, and do keys, we see all the stuff that you all have created. So again, there's a lot more depth of all this in the asynchronous videos. I'm not going to dig through all this because we're going to see some of this operationalized with our U.S. counties data set here in just a moment, including our sorted sets. All right, so let's take a look at our old familiar U.S. counties data set. And I really like using this data set kind of over and over again in these examples because it's a data set that we've now become familiar with. So we can kind of look at the differences in the database management systems themselves without getting caught up in the differences in the data sets, right? So we've seen this several times before. We'll take another look at it. So in order to get this into Redis, I have had to do some Excel magic, kind of similar to the creation of the DDL and the insert statements that we did for Postgres way back in live lecture number 2, which that exact segment from a previous semester is linked to right here. So if you want to take another look at that, you can always visit that link. But as I was thinking about the best way to do this, it seemed very much like it would be best to store this in hashes, where we have a key that is the combination of the state name and the county name, and then a whole bunch of values that are part of that hash that describe all of the different attributes, like your total population, your men, your women, your average income, all of that stuff. So the way that I did this, the Excel magic that enabled this data to get into Redis, looks something like this. And oh my gosh, what a hot mess of an Excel formula this is. But let's think through for just a moment about what we are doing here. So I'm doing an HM set. So that's a hash set for multiple values. And I am providing a key that is the name of the state and a colon and then the name of the county. Okay. Now there's nothing magical about this colon. We'll actually see a similar nomenclature when we talk about DynamoDB next week. But this is just kind of how I, as the database designer or as the application developer or whatever, have said that I'm going to format my keys so that I have the name of the state, then a colon, and then the name of the county, so then I can systematically know how to interact with my keys, right? So nothing magic about that colon, that's just how we're structuring it. And so after that, just this pattern of an attribute name, so county ID, and the value. And then the attribute name, in this case, total pop, and then the value. And then the attribute name, like men, and then the value, right? So just that pattern going for the entire thing. And yes, it's a very messy looking formula up here in Excel, but it gets the job done. So this is one thing we did. I'm going to show you another thing I did in Excel here in just a couple of minutes. But to get this into Redis, I'm going to flip over to a machine I have running in the AWS cloud that is on the same network segment as our Redis server. So just to kind of clarify what you're seeing on the screen right here, because there's actually, you're looking at the results of 3 different computers simultaneously. So all of this with the white background right here, my PowerPoint presentation is running on the desktop computer that is sitting about 1.5 feet to my right. All right, that's the computer that is in the room with me. Everything you see that has this blue background right here is a Windows installation that is running in AWS in an AWS data center somewhere in Ohio that's on the same network segment as our Redis and Postgres and Neo4j server that we've all been interacting with. Okay, so this white screen is my computer. This blue screen is a Windows computer with some of the same software that my computer has on it. And then these black screens are our shared database instance. And I have 2 black screens because this is going to be interacting with Redis. And then over here, we're connected to Postgres. And we're going to use this as kind of our opportunity to do some comparing and contrasting of things. All right, so that's kind of where we are right now. And I have a whole bunch of text files here at the bottom that have the different Redis and Postgres commands that we are going to be running. All right, so with that description out of the way, so this text file, what I have here is just all of those set commands that we previously saw here in my Excel magic that I have worked up. So as I previously mentioned, I can't copy and paste this in the Redis CLI, so we're going to have to connect via Netcat. Okay, so to use Netcat, I'm going to say nc to localhost, just the kind of name a computer can use to refer to itself, over the port 6379. That is our Redis port, as you are hopefully familiar with. And when I do this, I get nothing in response. And that's a little weird. That's actually a little bit atypical of most server applications. Like if you connect to a web server, or if you connect to CouchDB, or if you connect to Postgres, if you connect to anything, just a raw connection like this over the network, usually you get some kind of response saying, hi, I've got a web page I would like to show you if that's what you want to see. Like, hi, I'm CouchDB, send me a query. Redis doesn't give us anything, right? Because that would just be extra overhead, right? We don't need to know anything from Redis. All we want is the data. But if I want to verify that I am connected to a real working Redis server, I can type the command ping. And when I type ping, Redis responds with pong. Ping pong, ping pong, ping pong, right? I don't know. People in the open source community just are kind of clever and funny with how we do things sometimes. But ping just lets us know that we are connected to a live Redis server. If I type keys asterisk, I see all the same keys that we were just interacting with, right? All my MG student, all my student keys that were created by some of you all, right? So all that stuff is out there. This is the same Redis installation that we've already been looking at, okay? But at this point, I am going to clear everything out so we can just load our U.S. counties data set. So let me get to that. Okay, cool. So I'm just going to select all, copy this. I'm going to come over here. I'm going to say flushdb. says okay. Now if I say keys asterisk, we get nothing in response because I have deleted everything that was in the database. Sorry, not sorry. So I've copied this. I'm going to right click to paste this. But before I do this, I want to see just how long this is going to take. And I will remind you that when we did this in Postgres a couple of weeks ago, even when we created kind of our most efficient possible insert, it took like 7 seconds or so to insert all of this data, right? So I'm going to pull up my clock here and wait until we get to kind of a nice round number that'll be easy to kind of subtract. So when this gets to 40 seconds, I'm going to paste, and we'll see how long this takes. Paste and pull this back up. And gosh, just as soon as I got this pulled up, it had, in about 2 seconds, already pasted those 3,220 counties in the United States. So yeah, that is pretty quick, right? If I were to say keys now, I see all of my states with counties. Maybe I could provide a pattern, say something like keys, Texas, asterisk, and this gives us all of our counties that are in Texas, right? Keys, Arizona, asterisk. This is a much smaller set of counties because we have fewer counties in Arizona. If I said something like keys, Harris County. Recall we have a Harris County, Texas, and a Harris County, Georgia, so we pretty quickly can see that. If we wanted to maybe get something in particular out of our hash, we could use our hget command, right? So we could say hash get from the key Texas Harris County the value of the attribute total pop, right? And we see that the value for total pop for Harris County, Texas is 4,525,519, right? So doing this is very, very similar to over here in Postgres, and this is just a command line interface for Postgres. So we can do everything here that we could do in something like dbeaver. It's just not as pretty and user-friendly. And you see we have this my US counties table, and then another table that I'm going to talk about a little later. But this is very similar to saying something like select total pop from US counties where state equals Texas and county equals Harris County, right? Select total pop from US counties where state equals Texas and county equals Harris County. Same value as what we got from just saying hget Texas : Harris County total pop. Okay, just two different ways of interacting with the data in the two different DBMSs. And if we were to erroneously do just get instead of hget, we get an error message that says, hey, this is not the right number of arguments for get, right? And it's like, okay, well, I guess I don't know what the data type of this is. Okay, so if I just say type and then the name of this key, it tells me, oh, that's a hash. Oh, okay, so since it's a hash, I know now that I have to use my hget command instead of just get in order to interact with that. All right, so let's see. We got all of our US counties data into Redis, and we've seen how we can do kind of some basic searching, how we can do some basic querying of our data. Let's see. Oh, if we wanted to see all of our values, we could use the hgetAll command. Can't type. Texas, Harris County. And this is very similar to saying like select asterisk from U.S. counties where state equals Texas and county equals Harris County. We're getting all of our attribute names and the values that go along with them. And Redis actually does this really neat thing right here. This $12 is telling you the number of characters that it's about to send you, right? So if you're trying to rapidly read something in and you know it's going to send you 12 characters, you can stop listening after that 12th character, right? Then it says, now I'm going to send you 3 characters, 6.6, right? All about trying to be as absolutely efficient as we can be in everything that we are doing. All right, so we don't have a lot of like analytical capabilities built into Redis, particularly if we're using just hashes or something like that. But we do have this really interesting data structure of our sorted sets, right? So we said lists are ordered. That's just kind of by nature. If you've ever taken a computer science programming class, you know that lists are ordered data structures where sets are unordered data structures. But this sorted set gives us a really interesting situation where we can interact with the data as if it is a set, but we can also provide what Redis calls a score. And we can sort and do comparisons based on the value of that score, okay? So we're going to add items to our sorted set using this zadd command, okay? So this kind of deviates from the set get just a little bit, but zadd is how we get items into our sorted set, okay? So in order to do this, I once again did a little bit of Excel magic and I created these zadd commands. So I'm doing a zadd to a key called county populations, a score that is the value of total pop, and then a value that goes along with that score that is the combination of the state name and the county name, just like we saw before. So back over onto my AWS instance here, I've got, again, just the same thing that I've created in Excel over here, 3,220 zadd commands to create this sorted set. But before I do this, I want to actually clear out everything that is in Redis again, so it's real clear what we're doing here. So I'm going to again say flush db, and now if I say keys, we see there is nothing left in our Redis server at all. Okay, so I'm going to right click, or I'm going to select all, I'm going to copy, I'm going to come over here, I'm going to right click. I'm not going to time it this time because again, it's going to be blazing fast, you'll see, and it's already done, right? Before I could even finish talking about it, those 3,220 commands have been executed. And so now if I say keys, well, that's kind of wild, right? I ran 3,000 commands and it only created one key. Well, yeah, that's because we were adding everything to this one key called county populations. And county populations is just made up of 3,220 items, okay? So if I said type county populations, we see it is of a type Z set or an ordered set, okay? So if I run the command Z range by score against this value, county populations, and let's say we want everything that is in the range from 0 to 9999999, just whatever we think is going to be kind of above the maximum that we would expect, we're going to get back as a result all of our counties ordered by that value of score or ordered by the value of total pop, right? So this goes from our least populated county, which is going to be way up here at the top. Oh, it even rolled off the screen. I think it's somewhere in Oklahoma or Nebraska or something. Down to our most populated county, which is Los Angeles County, right? Los Angeles County is Los Angeles, Cook County is Chicago, Harris County is Houston, Maricopa County is Phoenix, Arizona, right? So these are the same largest counties that we've seen over and over again throughout our examples during the semester. If we only wanted to see maybe our larger counties, I tell you what, I'm going to drop out of this and I'm going to go into the Redis CLI so we can see some of the niceties that it affords. So in the Redis CLI, we have the availability of the help functions and some kind of autocomplete and hints and things like that. So, which we don't get when we're just connected via Netcat. So here, if I say Z range by score, and you see it kind of provides some tips on what we can do next. We need to provide the key, then the minimum and the maximum, and then optionally say with scores. Okay, so Z range by score for county populations. And let's say we only want to see our very large counties, one that have 3 million or more as the population, right? So we could say minimum of 3 million, maximum of a bunch of nines. And this time, let's say with scores. Great, we only get kind of our largest counties now, and we also get the actual population. So Orange County is 3.1 million, San Diego County is 3.2 million, Maricopa County 4.1 million, and so on. All right, so that kind of gets us through these basic interactions that I wanted to cover about Redis. So yeah, getting our data in, using hashes, using our sorted sets, being able to interact with our values like our populations just a little bit, right? So seeing how the data structures kind of give us some flexibility within Redis, how we might functionally use it. But the last thing that I want to talk about tonight is kind of quantifying how fast Redis is, because I've just kind of said this and I've given some examples of it being kind of fast, but also I've been kind of hand waving. We haven't had a real apples to apples comparison. So what I'm going to do is do some insertions of 10,000 and then 100,000 and then 500,000 records into Redis and into Postgres. And actually for Postgres, I'm only going to do the 10,000, and you're going to have to take my word for it on the 100,000, but we can kind of extrapolate what this would be, because I don't want to sit here all night, right? But we're going to do some inserts to some pretty large data sets and kind of compare a little bit. So as I previously mentioned here, I'm connected to a server in the AWS, on the same AWS network segment as our Redis and our Postgres server. Redis and Postgres are running literally on the same server, so this is a direct apples to apples comparison. There is no kind of underlying hardware difference that should come into play. And so the most equivalent commands that I can come up with to do these insertions is in Redis to say set test key 1, test value 1, right? And this goes from test key 1 to test key 10,000 and test value 1 to test value 10,000. And then in Postgres, to have 10,000 insert statements that say insert into Redis test, that's the name of the table we just saw, values, and then test key 1, test value 1, up through test key 10,000, test value 10,000. Seems pretty apples to apples to me. That's what I've got in these text files here. Let's see. So yeah, here are my 10,000 lines of inserting for Postgres. So we're going to copy and paste that and we'll time it. And then we'll do kind of the equivalent thing with Redis and we will time it. Okay. So in Postgres right here, if I do select asterisk from, I want to make sure I don't have anything left over here. Select asterisk from Redis test. Yeah, there you go. And you see we just have our two attributes, test key and test value. That's where we're going to be inserting into. Okay, so I'm going to select all, copy. I'm going to come over here. I'm going to wait for this to get to a nice even number. We'll say when it gets to 20 seconds, I'll right click here, then pull the clock back up and see where we are. 1920, paste, pull the clock up. So it looks like we're at about 4,000, 5,000, 6,000, 31. So it looks like that took about 11 seconds, right? Which is just not bad. Let's see. If we did 10,000 inserts in 11 seconds, that is 909 records inserted every second, right? So that's, yeah, that's really just barely over 1 millisecond per insert, right? 1,000th of a second per insert. Like that's pretty darn fast. Like I'm not mad at that. There's not many things that I can do 909 times in 1 second. But now let's give Redis a shot at this. So again, I've got to connect just via netcat 6379, and let's flush DB. Let's clear everything out so we don't have any confusion about what is happening here. And here are my 10,000 set commands for Redis. Right, so I'll paste this on 50. Paste and pull this back up. And I didn't even really get the clock pulled back up. I don't think it had hit 2 seconds yet. I'm thinking that was like a second and a half, maybe something like that, right? So if we said, 1.5 seconds divided by 10,000, or I guess 10,000 divided by 1.5 is what we want to do. Yeah, we were inserting 6,666 records every second compared to the 909 that Postgres was able to do, right? So that is a pretty significant difference, right? And yeah, and this is what I've seen in kind of previous times that I have executed this, that it's, about 10 or 11 seconds for Postgres to do this, and Redis does it in just under 2 seconds, okay? Now, if we expand this out to 100,000, Postgres takes about 2 minutes to do these 100,000 inserts. But in Redis, again, I'm going to flush DB, verify nothing's there, we're all clean. In Redis, we can do 100,000 records. Boop, there we go. So we're on about 25,000, 40,000, 60, 70, 80, 90, 100,000 in about 11 seconds, right? So Redis was able to insert 100,000 records in the time that Postgres was able to insert 10,000. So it's about 10 times faster at this point. However, I will point out this is kind of the worst case scenario that we have 100,000 individual set operations, right? And recall, we also saw ways that we could do insert statements more efficiently in Postgres, right? I mean, Postgres is kind of the worst case scenario here as well. So I want to do one more example with Redis, how we can do this in a much faster manner, okay? And also, let me just prove that our data is actually here. If I were to say get test key, and then any number between 1 and 100,000, 97,254, we should get test value 97,254, right? All of our data really is really is there. But if we were to do, instead of set, an M set, and set, let's see, and instead of setting one value at a time, setting 100 values at a time, let's see how long it would take us to insert 500,000 key value pairs. Go. Halfway there. About 9 seconds in that case. So we did 500,000 inserts in 9 seconds. Or about 55,000 write operations per second. Remember I said earlier in class that people say Redis can do up to about 100,000 write operations per second, and I said I've been able to push this to about 70,000. Right now, this ran at about 55,000 inserts per second. And of course, I could say get test key anything between 1 and 500,000, 497,621, and there's the value that goes along with that. But yeah, we wrote 55,000 records per second. Like, I don't know, man, that's fast, right? That's a lot of data coming through, right? But when we talk about big data, we talk about it having a high volume, a high variety, and a high velocity, meaning it comes in very fast. So if you think about something like and there we go. So of course these numbers may vary a little bit from what we saw here, but the general kind of realm, the order of magnitude of the difference is kind of what we expect here. But yeah, if you think about a situation where you've got a whole bunch of sensors that are taking readings, dozens or hundreds or even thousands of times per second, right? Like in a self-driving car situation where you've got your radar sensors and your camera and your proximity and all this stuff, and you've got dozens of these around your vehicle taking readings multiple times per second, like, yeah, you might need a data store that is able to consume these tens of thousands of write operations every second. That's where a key value store like Redis is really going to come into play, right? But often when you've got data coming in this quickly, it's something that you're going to need to make a decision about, within a few milliseconds or maybe within a second or something like that, right? In a self-driving car, you're getting thousands of data points per second, and you've got to make a decision in a split second to slam on the brakes or make a evasive maneuver or whatever. But then after that instant, the data with that level of granularity maybe isn't very useful anymore, right? So maybe you're using Redis to take in this streaming data, look for these outlier variables that need to be, or outlier values that need to be addressed, and then every 5 seconds, every 10 seconds, every something like that, kind of aggregating that data up to a less granular observation, and you store those less granular observations in your persistent data store like a Postgres or a MongoDB or what have you, right? So we get super fast, a little bit less functionality, and here are some of our use cases. Oh, and this is a great one. Maybe something that you have experienced before, but didn't really realize that something like Redis or Mcached was what was facilitating this interaction, right? But if you've had the experience of pulling up content on a website and that content loads very quickly, but then as you start scrolling down a little bit, you get a quarter of the way, a third of the way through the article, something like that, it's like it kind of jitters a little bit, right? It like pauses, or maybe it's like blurry, or the stuff hasn't downloaded and it like starts kind of populating as you scroll through. right? That's exactly the situation and one of the use cases we're talking about here. So this is what many like news sites and message boards and discussion boards and things like that will do is say you've got an article that is of a length that they think it's going to take you 5 minutes to read this article, right? We'll load the first 5% of that article into something like Redis, right? And so when you pull up the article, that first 5% gets immediately loaded and put in front of your face. And while you're, for the first 30, 45 seconds reading that first 5%, then we can go make a call to Postgres, MongoDB, HBase, whatever it is, and get the rest of the article and then populate that last 90, 95% before you've ever scrolled down to it, right? But if you load something and you scroll real fast, maybe you get to the part that needs to be loaded before that load operation has occurred, right? And it's not a big deal if you lose that first 5 or 10% of the article because your Redis implementation is ephemeral in nature, because you can always repopulate that data into your Redis server from your more persistent data store. So yeah, using Redis as a cache, using it as a to receive rapidly streaming information, doing things like that. These are kind of the use cases for Redis. So that is kind of the demonstration that I had for you all tonight. Go ahead and play around with it a little bit more. See if you can push the performance to the limit. But hopefully this has been a nice kind of overview and introduction to Redis. So next week we're going to be talking about another key value data store, or actually what's frequently referred to as a key value document data store, because our values in DynamoDB often are kind of structured in a document-like format. So I've heard DynamoDB referred to as just key value, as just document, but then I guess kind of the term I like the most is that it's a key value document data store. But we'll be talking about AWS DynamoDB next week. Again, in 2 weeks on November 19th, we'll be talking about the idea of polyglot persistence and using multiple different types of databases to store our data, doing a little bit of a holistic wrap-up of things, and then talking in a bit more detail about the final exam that will be coming up on December 6th. And then, of course, between our final regular class and the final exam on November 26th, you'll be having our second round of case project presentations. So I very much look forward to seeing that, and do be looking for here in the next day or two a link to sign up for another time to meet with me and receive some feedback on your case project phase 1. And I see a question in the chat. No progress quiz. Yes, no progress quiz. Sorry, it slipped my mind because the progress quizzes or the Kahoot progress quizzes are something new added for this semester, and yeah, that's just my bad. So I'll see if I can dig up the progress quiz questions and get those loaded onto Canvas, so you'll have exposure to those questions for preparing for the exam. But yeah, my apologies, I forgot to put together a Kahoot for tonight. So we can resume that soon, but if we don't have any other questions, that's what I have for you all tonight. Any final things that we want to address or talk about before we go see perhaps what states have determined their voting status?
Yep, no problem for that. No.
All right.
No
Well,
questions.
you all have a great rest of your evening. I look forward to speaking with all of you again soon. Go forth and do great things, and we'll talk again next week.